All right, operational amplifiers. Eugenie E. McAuthel, College of William and Mary, Week 9. Operational amplifiers. Voltage out, amps times voltage plus minus voltage negative. This is sometimes called the differential amps. Amps is open loop gain. Amp is frequency dependent. Amp is 10 to 5, 10 to 6 at DC. A is amps result in zero high frequency roll of limited operational bandwidth, typically megahertz or gigahertz range. Input impedance is higher than 10 to 6 or 10 to 14 ohms. Output impedance is low as 0.1 to 10 ohms. However, output current usually limited to 10 milliamperes. It is usually super easy to design with them. Sometimes with one transistor is enough of the op amps. The more expensive the op amplifiers are made with the transistor to understand the limits of the need to know how the transistor behave. Operational amplifiers require bipolar supply. Remember, the op amps cannot source a lot of current powers, while transistors can recall our transistor voltage control switch for a bulb. Some combine operational amplifiers and transistors for a power circuit. Others do a circuit with the operational amps. So we have a very bad amplifier, voltage in, voltage out, amp negative being ground. The gain of voltage out over the amp to voltage in. A depends on everything in the temperature, power supply, voltage input, voltage frequency, and so on. Non-inverting amplifiers. Now we have the voltage in going positive, voltage coming out, and also re-looping back around through resistor 2 to the amplifier and negative, and then regarding its second power of the divider, resistor 1 to the ground. And you have amp to the first and amp to the second. Gain impedance ideal with the operational amplifier. Amp is greater than 1. Gain ideal. Gain is equal to 1 plus R2 over to R1. Voltage in impedance is equal to 0. Voltage in is equal to infinity. Voltage out impedance in is equal to infinity. Impedance out is equal to 0. Follower buffer. Voltage in goes to the positive. Voltage out goes back to the negative. The amplifier voltage out equals amps over the amp plus 1 times voltage input. Gain impedance of the ideal operational amplifier. Amp is greater than 1. Gain ideal is equal to 1. Voltage impedance input is equal to infinity. Impedance output is equal to 0. Note that the negative feedback of the voltage positive is congruent with the voltage negative. The negative feedback is applied with the amplitude frequency is greater than 1. Open circuit gain of the frequency of the interest. There is no current into the input. Is voltage negative equal to voltage positive. Can have no ideal operational amplifiers where A is not greater than 1. The gain is equal to gain ideal parallel to the amp equal to gain ideal times amp over gain ideal plus amp. Inverting amplifiers show the resistor and the voltage in going through resistor 1 and then into the negative, sharing a series between resistor and amplifier and amp going out. That's an inverter amplifier. Gains impedance for the ideal operational amplifier is greater than 1. So the amp is greater than 1. The gain ideal equal to the negative resistor 2 over resistor 1. Voltage impedance input is equal to resistor 1. Impedance output is equal to 0. Note for the negative feedback voltage power is congruent with voltage 1. Summing the inverting amplifier. Now it shows a resistor 1, 2, 3, 4, and so many numbers of the series. And we're taking a inverter amplifier and running it in somewhere in between the resistor series for ideal operation amplifier. Amp is greater than 1. Voltage output equals negative voltage input 1 over resistor 1 plus voltage input 2 over resistor 2 plus voltage input 3 over resistor 3 to the voltage input number over the resistor number divided times resistor frequency, and you get the impedance input is equal to N or equal to Rn equal to impedance out is 0. You have a differential amplifier which runs a resistor between an inverter resistor with the two resistors also running on the loop of the positive. So we have the differential amplifier. Voltage output equals resistor 4 over resistor 1 times resistor 1 plus resistor 2 over resistor 3 plus 4 times voltage input 2 minus resistor 2 over resistor 1 times voltage input 1. And the impedance out is 0. Alright, Chapter 9, Operational Amplifiers. Operational amplifiers, or op-amp, is ideal simple amplifiers on an integrated circuit that contain with a discrete with the components with the resistor capacity for the transistors all made at the same time with the same place with the silicon put into the standard package. Most circuit design have already been done with the use of the particular ECU with the op-amp has for the almost infinite impedance and very low the output impedance extremely high gain of 10 to 5, 10 to the fifth, of the typical will assume the gain of these devices so long, never use the simple amplifiers. Instead, you will reduce the gain, make it stable, more stable than negative feedback. So, might ask you, we do not start here with a skip of the components that go into the op amp. The op amps require two power supply, usually positive negative 15 volts. They cannot dissipate too much power. If you have a similar job, high power with the transistor is better. You find that yourself putting together such as several elements that you should probably be using an op amp. Op amp with the two inputs and inverting with the input negative voltage of the non-inverting voltage positive. The one output shown in the voltage shown in 9-1 over the right with the fundamental region of the governing operation. Op amp is the output open loop of the gain amps times the difference between the input voltage. Figure 9-1 show the op amp voltage output is equal to amps times voltage power positive minus voltage negative for the gain is so large effect with the required voltage power equal voltage negative for the op amp with the normal operating range. The lab week will use the an op amp with at least two other connections too, but they typically require the two separate power supply inputs of the plus or negative 15 volts, sometimes ground, sometimes frequency compensation, possibly output trimming. Output trimming enables you to set the output voltage to zero with the two inputs tied together. The symbol of the amplifier with the triangle with the input with the one side with the output with the on point on the other side. Extra connections like a power compensation frequency control shown with the indicated connection size of the triangle. The op amp golden rules: give it a high impedance with the near the finite with the gain with it is analyze with the op amp performance with the normal operation negative feedback. The op amp will follow these two golden rules. Op amp draws no current into the input. Op amp will do anything it can to the output to ensure the two inputs have the same voltage. Negative feedback. The negative feedback will couple with the output signal to become back to the invert input with some way. The simplest form of the negative feedback force of the op amp with the output with whatever the required inch for the two inputs for them to have the same value or so voltage. We define the two different gains of the op amp for the open loop gain with this gain without feedback for the output with the inverting input with the closed signal, closed loop gain with the gain with the circular feedback for the output to the inverting input. The follower or voltage output and voltage equals voltage input. Simply op amp circular feedback. It can be immediately simply connecting with the output directly with the inverting input is shown figure 9-2 with the right with the change of the op amp with the will change of the output with the make the inverting equal to with the non-inverting input. The unity gain device make it those with the made a single transistor example one from the better input with the output input of the file with the frequently called buffers since they can be used to isolate one sub circuit from another. The op amp follower or buffer. Inverter amplifier for the gain, maybe the inserting with a couple of resistors to feedback system shown figure 9-3 for the golden rules op amp the resistors of the output to make the inverter into put by the same with the non-inverting input with the ground, therefore with the voltage drop with cost resistor 1 the voltage input with the voltage drop with cost resistor 2 voltage output. So if the input cannot sync the in current with any current with the current through the two resistors must be equal to 2 to make this happen. The output and input voltage are related. So we have a voltage output over the resistor 2 is equal to voltage input over the resistor 1 equals 0. Gains are defined with the ratio of voltage input voltage equal over voltage input, hence the gain with the ratio of the gain of the resistor 2 with the radio over resistor 1. Notice this most of the time they use the feedback resistors 100 to 1 to 100 kilo ohm range. Non-inverting amplifier. A non-inverting amplifier can be made with the two resistors shown figure 9-4 with the analyst very similar with the previous example. The voltage dropping off the resistor 1, the voltage input with the current flowing through resistor 1 and resistor 2 resistors will be the same to cover the inverting input with the draw of no current used and can be shown with the gaining is may be available by gain equal to voltage over the voltage input equal to 1 over the resistor 2 over the resistor 1. We can also know with the follower adjusted to non-inverting amplifier resistor 2 with 0 over the N and infinite resistor 1. So figure 9-4 shows your non-inverting amplifier. Currents between resistor 1 and resistor 2 will be the same. Summing amplifier. Some of the inverting input with the op amplifier virtual ground 1 could not connect the number of the inputs at the same point with the result of the summing amplifier is shown in figure 9-5 with one of the example used is the DC offset with the bias with the same wave with the blocking on the DC input for the capacitor. Some limitations. When the op amp is nearly ideal, what it does is they have the limitation good to find with the limitation every top is going with the jam, the proper real circle with the will try the lab. Amplifier can model with the op amp with the open loop game with a large part of the but infinity open loop game is usually frequently dependent to with a feedback loop to actually redirect the fraction output with the current back to the inverting input with the fraction of the output with the return to note with the bay by B. A small finite current with it is being drawn into the input with not quite with the same, and the only can be driven with a limited amount of the current, even though with low output with the impedance. We will discuss each of these issues in the following section. Finite open loop gain. The open loop no feedback closed loop gain in a feedback loop are related by gain equaling A over 1 plus A times B equal to 1 over BA to the negative reverse, where gain is a closed loop gain and A is an open loop gain. The example of the application relationship is given with the gain and inverting amplifier with the closed loop gain needs to be modified with include with the effect of the open loop gain with the putting in a parallel with the gain to do the feedback resulting in gains. Gain is equal to 1 over the amps and plus for the resistor 1 over the resistor 1 plus resistor 2 to the negative first. The common way with the indirectly measure of the open loop gain with the measure however the circle with the gain with the derivative of B to the negative first open loop gain is equal to B negative first total gain and half of the B, the negative first finite input current. Alright, since the inputs can sync with the draw with the show with the current with a good idea of the match for the impedance for the scene with the two input to make it not more perfectly non-inverting amplifier, we can introduce the third resistor and the non-inverting input with the invert put must be the voltage divided third resistor of the be chosen to have the same resistance the resistor 1, resistor 2 parallel with the figure 9 sync with the impedance band with no inverting amplifier. So, alright, voltage in go through resistor 2, coming out voltage out, and being the negative running resistor 1 and 2. So resistor 1 and 2 are parallel. Slew rate. The output voltage can only change as fast as the due to the internal capacity of the op amplifier with the U with the control of the change of the slew rate with the circle of the maximum rate at which the output change with determines the frequency of the useful of the amplifier particular amp. Voltage compensation. Internal components of the op amplifier, like with the transistor input, with the general, with the not indicated identical with the often leave, which looks like artificial voltage, the difference of voltage offset between the inverting and non-inverting inputs. But most of the op amps have the option to trim the input so that the effect that can be eliminated. Examples of how to make the corrections are shown with the data sheets on op amps. Op amp frequency compensation. An op amp gains with the DC with a very large degree for the increasing frequency, so the amp consists of the several district amplifiers following each over each of the states will have their own frequency limitation model simply with the low-pass filters. Low-pass filters introduce the 90-degree phase shift of the frequency higher with the frequency 3 decibels higher with the high frequency variable internal amplifier stages will produce the net phase shift with at least 180 degrees. Since the 180 degrees phase shift is the signs reversal in terms of the negative feedback with the stabilizes the current circuit, stabilizes the circuit and positive feedback with the drive of the output to the rail. Some of the important of the game of the op amp circuits have the degree of loop gain with your circuit no longer than one time of the net phase shift that equals 180 degrees. Adding circuits over the allow with a high frequency path for the second state with the amplifier chain with a typically due with the low pass filter limits for the gain to be less aware of the phase shift and it reaches 180 degrees. Most of the op amps will either internally compensate with the distribute the phase for the constant is over the wide range of frequency, even if the op amp with the open loop gains of the holds true until the open loop gains falls about 1. Some of the ops comes from the version either uncompensated or decompensated, but not completely compensated. You can be added with the capacitor externally since your loop gain may be less than open loop gain. This lets you use op and operational amplifier for gain at a higher frequency than you can get in an internal compensated version. And it goes into design exercises in a lab, and that was chapter 9, operational amplifiers.